Stop.
The VMU is the velocity minimum on stick. It is the absolute minimum speed at which an aircraft can take off. How is it determined? The lift of a wing is produced by the speed of the airflow around the wing and depends on the angle between the airflow and the wing. This angle is called angle of attack. When the main wheels are on the ground, the angle of attack is limited to the value obtained when the tail touches the ground. If the aircraft accelerates in this position, the lift increases as the speed increases, while the angle of attack remains at the same value. At a certain speed, the lift becomes equal to the weight, and the main wheels and the tail leave the ground simultaneously. This speed is the VMU. The VMU must be known for each aircraft configuration, as the takeoff speeds used by airline pilots must incorporate a margin with this speed. Additionally, during the initial phase of the development, VMU tests may be used to optimize the aerodynamic configuration by choosing the best flaps deflection to reduce takeoff distances. For this test, a tail bumper protects the rear part of the fuselage. For the determination of the VMU, several takeoffs are performed with the tail bumper scraping the runway during the end of the ground acceleration phase. With a lot of sparks coming from the tail bumper, it is a spectacular test for the observers. The VMU tests are among the trickiest to perform, as there is a significant risk of damaging the rear part of the fuselage, either with a strong touchdown of the tail bumper or with an impact behind the bumper just after liftoff. The flight test technique for takeoff is completely different from what is done in normal operations on a transport aircraft. All tests are performed in direct law, where the pilots control the surface's deflection directly. One of the pilots puts his seat in a low position. He does not look outside during the test. He flies only the pitch attitude presented on his flight display. From around 100 knots, he pulls on the stick until the tail bumper touches down smoothly on the runway. He keeps the stick in the rear position to maintain the contact with the ground. Then, just after liftoff, he controls the pitch attitude accurately, as the regulations require that it should not be reduced below the value at liftoff. On the other hand, it must not be too high just after liftoff, as otherwise there would be a risk of touching the runway with the fuselage behind the tail bumper. The margin between this liftoff attitude and the minimum required for acceptability of the test is very small, around 1.5 degrees in some cases, and therefore high precision flying is required. It is one of the key difficulties of the test. The other pilot puts his seat in a high position in order to see the runway when the aircraft is in a high pitch attitude. During the rolling part, he controls the aircraft with the pedals to maintain the runway axis. When airborne, he maintains the bank angle close to zero with very small inputs on the stick. He is also responsible for the overall safety of the takeoff. He takes controls at the end of the test. Several tests are performed with a low thrust, giving a minimum rate of climb. It happens sometimes that the thrust does not allow the aircraft to be flown out of the ground effect, and it is trapped very close to the ground. When the climb slope is not sufficient, the second pilot performs a go-around. He takes controls and applies full thrust. In the cockpit, a test flight engineer sits between and slightly behind the two pilots. He is in charge of precisely adjusting the thrust. He also carefully monitors the engines and the systems. Due to the nature of the test, non-standard procedures are defined to cover any engine failure case. In the cabin, 2 or 3 flight test engineers coordinate the tests. They also validate them and check that the execution is in conformity with the regulations. They may also amend the following tests according to the results found. For example, they may decide to increase the thrust if it appears that it was not sufficient previously, or cancel a test if there are already enough data to reach a conclusion. For aircraft with short fuselage or business jets, the pitch attitude is high when the tail bumper is in contact with the runway, and therefore the VMU is very low. The VMU tests are performed with a different technique to minimize the risks of damage. A high pitch attitude with the tail bumper not in contact is maintained during the takeoff. The takeoff speed obtained is low and is considered as a VMU with no effect on performances. This technique was used for the A318 and A400M. For each new program, between 20 and 30 VMU tests are performed with different flaps deflections, thrusts and weights. Obviously, if the length of the fuselage is modified, new tests are needed.